We are now ready for problem 11 on this review. So let's go look at it. So let me find this. There it is. All right. It's like a story problem. So let's read it, then we can talk about it. The number of visitors to a website, the number of visitors P to a website is given in a given week over a 1 year period is given by, and here's this equation. Looks pretty messy. Where T is the week and T goes from 1 to 52. Then there are 3 questions. The first question talks about during that year, which weeks are the number of visitors decreasing, which weeks are the number of visitors increasing, and see if there's a critical point, like a max or a min, and what does that mean? So in other words, now we take a real life situation where people are going to a website, and of course, the number of people going to a website goes up and down. And they have come up with this equation that predicts the number of people that go to their website. So they want to know during what time of the year, during what week of the year, are the number of people increasing, what week are they decreasing, and if there are any maximums or minimums. So this is an example of where we're going to use the first derivative to solve this story problem. Because what we're really going to do is we're going to look for a max or a min, and then from that we can determine the intervals of increasing and decreasing, and then we'll have the answer to the questions. So let me write down this equation, and then we'll start working on it. So this is an example of how to use calculus to solve sort of like real world problems. So P of T equals 120 plus, in parentheses, T minus 83 e to the 0.02 T. And T is from 1 to 52. T means a week. So basically we're looking at 1 year. So really, from T going from 1 to 52, they want to find out when is the number of people increasing, when it's a decreasing, is there any maxes or mins. So this is the number of people visiting the website, and T is the week. So whenever you have a problem where you're looking for increasing and decreasing and maxes and mins, that's always a tip off that you're going to use the first derivative to try and answer those questions. Now normally, all the kinds of problems we've done have been typically like f of x equals 2x squared plus 2x. And we get used to, like, the first derivative we would write as just 4x plus 2. Or sometimes we had y equals 2x to the 5th, and the first derivative is dy dx. So the problem is we use this notation, you become familiar with it, but then when you get to these story problems, what happens is the variables change. In other words, in this case, you have to think of the p in the back of your mind, sort of like the y, or the p you could think of as sort of like the f of x. And then over here, the variable t, in the back of your mind, you treat it like the x. So sometimes students get hung up because they're so used to working with x's and y's and f of x that when they have different variables, it confuses them, but it isn't really that difficult. So if we're going to take the derivative of this with respect to time, t is my variable, so like x, so I'm going to take the derivative. First of all, derivative of this constant is 0. Now it looks like I have my variable inside the parenthesis, but I also have a variable up here in the exponent. So this looks like we're going to have to apply the product rule to take the derivative. So when I apply the product rule, I write the first sort of function, so t minus 83, and I multiply it by the derivative of the second function. Derivative of this natural exponential, you remember you just copy the whole exponent, and then you multiply by the derivative of the actual exponent. Derivative of 0.02t is just 0.02. So that's the first half of the product rule. Copy the first, derivative of the second, plus the second times the derivative of the first. So if we take the derivative of what's inside the parentheses, derivative of t is 1, derivative of a constant is 0, so it's basically just going to be 1. So if I sort of rewrite this, especially this first term, I have 0.02 e to the 0.02t times in parentheses t minus 83 plus e to the 0.02t. So really we have two terms here. This first one's pretty big. It's got like 3 factors, this coefficient, this exponential, and the parenthesis. I'm going to go ahead and factor out the exponential because it's the same in both. So I have 0.02t minus 83 plus 1. I should go ahead and maybe multiply out these parentheses. .02t minus, I might grab my calculator, make sure I don't mess up, 0.02 times 83, 1.66 plus 1, which further simplifies down to negative 1.66 plus 1, so e to the 0.02t times 0.02t minus 0.66. So this is the derivative, or the rate of change of the number of people that are visiting the website per week. Now, if I want to find the regions of increase or decrease, then I have to go find the critical points. Critical points meaning if there are any maximums or minimums. So how do we determine maximums and minimums? You take the first derivative, which is right here, and you set equal to 0, and you solve this equation. So now I have to solve this equation right here. Now, in a sense, it's already factored. So the solutions are going to be whatever value of t causes this exponential to equal 0. And then whatever value of t causes the parentheses to equal 0. Now, the first thing I hope you realize, or maybe you don't, but when you have your variable up here in the exponent, and I ask myself, what number could I plug in here for t that would cause the whole exponential to be 0? As it turns out, it's impossible. There is no solution. There's no value of t that I could plug in here to cause this whole first term to equal 0. I could make it very, 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 very small. I mean, so small you can't hardly see it, but it's still not ever actually equal to 0. So if I'm looking to solve this equation, there's no solution from this first factor. Now I look at the parentheses and I say, okay, what value of t would cause the parentheses to be 0? So in this case, easiest thing is just to take that whole parenthesis, set it equals 0, and solve for t. So if I add 0.66 to both sides, then I divide both sides by 0.02. So what this is saying is, this is the solution of when I set the first derivative equals 0. This is like a critical point. It's either max or min, but I don't know which. I'm going to go ahead and so I have a choice here. You can maybe do it sort of graphically, or take the second derivative. I don't really want to take the second derivative. It could get sort of messy. Let's see if it's pretty easy to do if I just sort of sketch it out. So I know 33 is the critical point. Let's see what happens to the first derivative on either side of 33. So for instance, I could put a 1 in here. So if I put 1, once again, here's my first derivative. If I put a 1 in here, this parentheses negative, this is positive. The derivative in this, what I call region 1, is negative. So that means that the actual number of people visiting the website is sort of decreasing. Let's see what happens on this other side of 33. So say if I look at when t is 35, the exponential is still positive. I got to see what happens inside the parentheses. So what's 35 times 0.02? And it's 0.7, so it's positive. So this region 2 is positive. So what I think happens is at t equals 33, we have a minimum. And therefore, everything to the left of 33, it's decreasing. To the right, it's increasing. So I would say that decreasing is going to be week 1 to week 33. And then increasing is week 33 to 52. So it must be a dip there in the middle, and then it starts coming back up again. So let's look and start answering some of the questions, and hopefully we've done this correctly. Over what interval the number of visitors is decreasing over the interval? I said from 1 to 33. That's good. Increasing, I said from 33 to 52. All right. Critical point, type an ordered pair. All right, well, we know it's 33, but I don't know the number of people. So I've got to go back. I guess I can show you. I've got to plug in t equals 33 into my original equation. Looks sort of messy. That's what I have to do. So I have to go P of 33. So 120 plus 33 minus 83 e to the 0.02 times 33. Now this is definitely a calculator kind of problem. Let's do this first, the exponential 0.02 times 33, and that becomes the exponent. I can see here this is minus 50, so I'm going to take this times minus 50. And then that plus 120. 23.26. I'll say 260. We'll see if they want us to round it or whatever. Type an ordered pair, type integers or decimals, rounded to 3 decimal places. So 33 and 23.260. So 3 decimal places, 0.260. We'll see if they like this. All right, that's good. Interpret what the critical point means. We've already talked about this. Critical point means the number of visitors was a minimum, minimized in the week. It's week 33. Now they say round to the integer. So 23.26 is rounded to 23 visitors. All right. Here's another graphing problem. Maybe we can just look at it and figure out the answer. Well, the interval shown for which graph is, so it tells us 2 things. First derivative positive and second derivative negative. So these are the graphs of the functions. What does a positive first derivative mean? Remember, a positive first derivative means the function is always increasing. As you go from left to right, the function is always going up. So before we even look at the second derivative, let's just look and see which one of these qualify. In other words, A, look at A. Function's decreasing. So it's definitely not going to be A. Look at B. Function's decreasing. I've already limited A and B. Get to C. C, function's increasing, so C is a possibility. Look at D. What's going on with D? It's horizontal, it's flat. The function is not increasing. And E, function's increasing. So far, we've learned that the answer has to be C or E. So figure out which one's correct. Let's look at the second thing that we're told. The second derivative is negative. What does it mean to have a negative second derivative? Negative second derivative, remember, a negative person is like someone who frowns. And what does that look like? That's concave down. It's like an umbrella. So second derivative negative means concave down. C, this is concave up. E looks concave down. Therefore, my guess is E is the correct graph. All right, I'm going to go ahead and stop now because this is a whole new topic. Now we're getting into vertical asymptotes. So let me stop now because I'll take some time before this next problem and try and explain the whole idea of vertical asymptotes. It's not very difficult, but I'll take some time to explain it.